Welcome to yet another exciting installment of the EpicEarth podcast. If you're someone with a thirst for knowledge in the realm of STEM and you're curious about the interesting and quirky experiences in the world of research, you've landed in the right place. This is episode 24, Rolling on the River. So don't forget to hit that like, follow, and subscribe button, then kick back, unwind, and prepare yourself for an exhilarating voyage around this epic Earth.
I found it all so fascinating, just learning all the information.
Nobody told me I couldn't do it, and I loved it.
And now I know how to learn. Like, this is a doable thing.
You know, that's an impact that we can't ignore.
We're back with another episode of EpicEarth. I'm Ashley Bosa, one of the hosts, and with me I have my other co-host, Brian Rosenblatt.
Hey, happy to be here.
And the third co-host, Scott Gavin.
Hey, y'all.
Today I'm excited to introduce our guest, who is not directly associated with BSU, but is in some ways associated with BSU. She majored in civil engineering in Chile, and then moved to Boise for grad school. So that's going to be an interesting story for her to tell us about. She's currently doing her PhD in civil and environmental engineering at the University of Idaho. And she mostly focuses on hydraulics and hydrology, or what she likes to call river science. So we're really excited to hear about her story. So welcome, Nicole Hucke.
Hi, thank you. I am very excited to be here. Thanks for having me.
Yeah, we're excited to have you on and to explain to us about your research and your science and your background and like growing up in Chile. That's really awesome. So welcome, and I guess we'll get started. And do you want to tell us a little bit about what makes you you?
And now,
what makes you you?
All right. What I've heard about previous episodes in this podcast and what I really like about it is that whenever you have a guest speaker, it's very lax in terms of who makes us us, right? In both a professional and a personal sense. And so I like to think of myself in both the professional Nicole and what just makes Nicole, right? So in a professional sense, I consider myself as like a huge water person. And by this, I mean someone who really values the study of water as a resource and its quality, management, distribution, because it is, as we all know, really essential to life. And we're basically composed of like 75 to 80% water. So it's technically in our blood. So since I majored in civil engineering, initially it was a lot of like concrete design, structural analyses, which is all like very heavy math. And also very important for society, right? But as soon as I started taking like hydraulics and starting to learn more about what a civil engineer can do in terms of water, I fell in love with it and slowly started to go more into the environmental side of it as well, and how we can protect it as a resource and why it's important to understand all the dynamics and everything that happens within watersheds and groundwater wells, which is all interconnected and very valuable. So I'm very passionate about that. I love river restoration. I love environmental hydrodynamics, all that good stuff. And on a more personal note, I am simply a Chilean 25-year-old trying to make the most out of life. One of my virtues, which I also think can sometimes be my major downfall, is that I am very curious and I love trying new things or learning new things as well. This is to the extent where I have like a lot of hobbies as well, but I am not like particularly good at any of them either, because I'm like scattered all over the place.
Yeah.
And I say this is my downfall because I'm very prone to just like always saying yes to new things, which can sometimes not be like very beneficial to me, or consumes like most of my time. So I think that's a bit about me. I also think of myself as someone who's like very perseverant, which is a very important quality when you're in graduate school. For all the grad students listening, we know how hard it can be and how much we get knocked down, and it can be really tough to kind of pull ourselves back up. So I think that being perseverant is also like a very valuable quality in a researcher. So I think that is like one of the reasons why I've been sticking around this long.
Yeah, I do see that even in myself, that perseverance is like what most of us hold on to in order to get through grad school. And it's one of those, like, you know, existential life crises that you have every like other day with your life, or like, you know, you're questioning like, well, why is grad school this way? Like why is it so hard, and why are students often struggling with like the normal day to day, and like why is it just this sometimes cloud that just hangs over grad school? But yeah, I think it's great to have that quality of perseverance. It's not necessarily that you need it as a grad student, but it certainly helps.
It does.
And I honestly would say that it's not a bad thing that you dabble in a lot of different hobbies. I think that's awesome. I think most of us actually, including all three of, you know, the hosts here on the show, are very interested in always trying and learning new things, and all of us have trouble saying no because we are always like curious, right? We're like cats. We're just curious. We want to know everything. We want to be everywhere.
And everything is so fun and interesting. It's like as soon as I meet someone that has like some hobby that I haven't tried, for example, climbing. I've never done any kind of climbing, and I'm very interested in just trying it out because it's like a huge thing here in Boise too. And yeah, just things like that, which is like really fun, and
that's
I just want to try it out.
Yeah. No, I think that's a great quality. So, well done. You're doing awesome.
You have all the right qualities for research, I would say.
Yeah, absolutely.
In my experience, it's like, I feel like 80% of grad school is just persevering, because you're going to get to a point where you have all the skills you need, but things aren't going to go your way. So you're going to have to keep going and going and going and going and going, and then you're going to do it. And it's going to be awesome.
Hopefully it'll be worth it.
Yeah, it will be.
Definitely.
I'm not even sure I'll reach that during grad school. I think I'll reach that point far into my career where I feel like I've gathered all the skills that I need in order to like. But
yeah. Even now, like I don't even know if I have like all the skills that I need. Like every step of the way, it's like I have to learn this new thing, or I have to do this other thing. Or really recently, I started TAing and like actually teaching. And it's very strange to be teaching something that I don't think of myself an expert on, but I'm still doing it. And I think a lot of people like in grad school also do it as well, where we're just teaching people about something that sometimes we're just, we just learned the night before or something.
But I think like the thing there is that sometimes you actually learn and retain more when you teach something to someone else, because
it's true. Then
it's like, okay, I really have to like kind of know what I'm talking about when I'm standing in front of a room of 25 students.
Absolutely.
And, yeah. And Brian could probably speak to that. Like, are there a lot of physics concepts over the last like year or so that you're like, I don't quite remember this? And
well, I definitely realized like teaching fills in those gaps that you didn't realize you didn't have. You didn't realize that you did have. But also I had to TA an oceanography course once, and I just did physics for undergrad, so I hadn't taken any oceanography class, and I don't remember a single thing about that class anymore now. I just remember struggling through it to like get it done because I didn't know what was going on. So there's a level there where if you have no background in it and you're TAing, that's like not a great combination in my opinion. But yeah.
You're like, well, I know oceans, I know they exist, there's things that live in it, but
I had to be reading the textbook along with them, like doing the activities to make sure I actually knew what was going on, which ended up just being a ton of effort. So yeah.
You know, in the words of Rihanna, fake it till you make it.
Yeah, that's exactly what I still do to this day. So,
aren't we all? Yeah. I'm sure even some of the professionals are still faking it till they make it. So, well, awesome. Well, we're glad that you get to share at least your confidence and your experience with us here at BSU, because you are a valuable asset to the sciences and. Yeah, and to the river sciences especially. That's so cool. I'm actually taking a fluid dynamics class. It's a fluid mechanics class right now. Oof. I'm auditing it because there's no way I could
it's take a lot class. Of math. It's complicated.
Math. It's just math. Yeah. But the professor that teaches it is so wonderful, and I'm like, wow, like this would almost make me want to change into like a an engineering.
That's what happened to me.
I know.
Totally, like fluid mechanics are so fun.
They are.
And they get way more fun when you get to actually apply it and not just like in the empirical sense of this is the equation for like the velocity distribution. You know, it's like when you actually know what it's for or what to use it for, it's when it actually gets fun.
Yeah,
that's what I think is so fun about geoscience in general. It's just like all the math that I thought was boring as a kid, like now it's cool because it's applied to like rivers and I can see it and I can like have data that shows something that I learned in school and I just never knew that I would be using it, but here we all are.
Yeah, that's awesome. So it's like, I know we've talked about that before, like the applied math is really where it like makes it happen. So
actually not even that, but applying the math and then going back and understanding just the math alone. Like after you've then applied the math, you get a deeper understanding of like the actual math itself. So like it works back the other way as well. So
yeah. Definitely. Sometimes deriving the equations first isn't always so helpful. Sometimes going back and being like, oh yeah, okay, I understand how this is applied. But I am having nightmares about rho and a bunch of stuff right now, which okay, so going off of that, what made you interested in your field of study? How did you get into sort of the civil engineering side of things? I know you talked a little bit about like how you got into like hydraulics and hydrology, but
yeah, it's a deeper story than just a hydraulics class, right? But it did essentially start there.
Yeah.
It was like around my second year of my undergrad, I think, and my hydraulics professor and my fluid mechanics professor was the same person. He was really cool, really awesome. He was really passionate about what he was teaching, which is something that really inspires students to like do well in their class. And I think how he taught the class made me really appreciate just water in general, and it made me want to like look deeper into it, and he saw that in me, I think, in some way, and so he invited me to be part of his research. He was doing like his last paper for his PhD at the moment, and it had to do on like shear stress distributions on rivers, and I obviously said yes because it sounded amazing, and I barely knew what shear stress was at the moment. And he taught me how to do a lot of like 2-dimensional simulations and numerical modeling, which nowadays is really valuable for a ton of other stuff. So I learned a lot, and after contributing to that research and being part of that paper and like meeting other river scientists as well while working with him, made me realize that this is something that I can pursue and that I honestly really want to.
That's awesome. That's really cool. It's really nice to have a professor that inspires you so much in a certain direction. I value those people a lot.
Yeah, it's really important.
Sometimes they can be rare in some of the fields, but there are definitely people who are very like passionate and enthusiastic about what they do and can share that passion and enthusiasm, and it sort of just is like osmosis. Like you just gain all that passion and enthusiasm for it.
And it came way easier than everything else too.
That's awesome. That's really cool. I had my undergrad advisor would have said, because I was the same with volcanology, because I was excelling in all my geology courses, and I was like, I think I finally found the right profession, and he was like, I think it found you. Like, so, you know, it is the profession does find you sometimes, you know, and that's awesome. It's super awesome to hear that you're like very passionate about this, and that I think that will just, you know, excel your career and all the things that you're going to do like with your degree. So.
Yeah, I can't think of myself doing anything else, honestly.
That's awesome.
So I'm very glad that the career did find me.
Yeah, that's super great. So what kind of research are you working on right now for your PhD?
So the project I'm working on now is, I like to think of it as very like interdisciplinary, because it goes really out of what I was used to, which was just focusing on hydraulics, which is a very like physical science. Just as a summary of what my research is basically studying the role of sediment transport on the release of nutrients and suspended sediment in rivers, because they have like huge seasonalities to them, and we want to see how the threshold of like when sediment transport occurs will affect the seasonal patterns of these nutrients or suspended sediment. And so it's a lot of chemistry. It's a lot of like soil and groundwater work as well, because you need to know what the contribution of groundwater is to certain solutes and stuff like that. So it's been a huge learning curve of being both in what I know of, which is just the sediment transport part, and all the other part of just like nutrients and all the lab work and everything like that.
Yeah, that, I mean, sounds like a lot, but it sounds really cool too. Like, I love how people can take like different disciplines and relate them to their research. Where exactly is your research? Do you do it here in Idaho, or are you based somewhere else?
So I'm not working in Idaho. I'm just here because this is where the university is. But I do field work in New Mexico, actually. My river, or like my study site, is in a river in the Valles Caldera National Preserve. So it's like northern New Mexico. And the reason we chose this like river in this watershed specifically is because it's like very secluded, so it doesn't have like any urban inputs or anything, and it's like the toppest river that you can find like in that watershed, or like one of the so it's the first tributary to like the East Fork Jemez. Okay. So there's virtually nothing above it. Yeah. And it has like some groundwater input, and we kind of just wanted to separate it from any other potential input so we could see what those interactions are.
That's really cool. It's like a natural laboratory.
It is. Yeah. It is technically, yeah.
That's awesome. That's really cool. And what a beautiful area to do your research in.
It's amazing.
Yeah. Yeah. If you've never been to northern New Mexico, I highly suggest it because it is really beautiful.
I second it. Yeah. I second it for sure.
The Valles Caldera.
Where Sequoia National Park is?
No, that's
Sequoia's in California.
That's California. There's Bandelier National Park.
Bandelier.
I think that's a national park.
Yeah.
And there's like Los Alamos, like that whole area, like Jemez and stuff, is just like phenomenal.
It's so different from the rest of New Mexico too, because like it's at higher elevation and has like its own microclimate. Yeah. Yeah. And it's the other reason that we chose it is because it's both snowmelt dominated, like in the spring months, and during the summer it has heavy monsoon storms.
Oh wow, okay.
So yeah.
Different dynamics going on
it's
in
beautiful.
the same season.
Yeah.
And it's really fun.
It's like Chama, like that whole area is just, I mean, yeah, you should go visit.
I will.
It's awesome.
Probably this summer, yeah.
Yeah.
The elevation must be like over a mile over there, is it?
Yeah, it's super high.
Yeah, I think like it's probably, I mean, Alamosa sits at like, it's like a mile high. It's like, or no, it's 7,500 feet.
Okay, yeah.
And so, like, probably in that area of New Mexico, like, yeah, most of those areas are probably above 8,000, like, higher elevations are probably
it's like 7,000 feet in altitude.
Okay, yeah, that's what I was
according to Google.
Yeah.
Yeah, so.
It's pretty high up.
Yeah. It looks a lot like Colorado, actually. Mm-hmm. It's like, so that's how different it is from the rest of New Mexico.
Yeah.
So.
Yeah, you go to Santa Fe and it's a complete different story.
Yeah. Yeah.
And they're 20 minutes apart.
Yeah.
So what is the best or most fun thing about what you do?
It's definitely the field work.
Mm-hmm.
I go twice a year for spring and summer, like I mentioned. And I think it's just that, being in the river, installing my things, and actually seeing the science behind it as well. Because we were talking previously about like the equations and like just modeling, where I get to see all these things happening on my computer screen.
Yeah.
But being out in the field and actually seeing it happen is so, it's endearing in its own way, and it makes me feel like I'm actually like doing an impact in like a real river rather than just like simulating things, right?
Yeah.
And it's also just incredible to be out in nature, and like you mentioned, like the field site itself is incredible, like seeing the wildlife and being able to explore a place is really fun. We get to stay after hours, which is where all the wildlife comes out as well.
Oh,
so
yeah,
it's really fun.
Do you have any interesting wildlife stories?
I was saving that for for the funny story part, but the one that always comes to mind when people ask that is I once had elk just poop all over my antennas. It was really funny. It was like 5 p.m. or something. We had gone to lunch and then came back to like wrap up the field day, and I was like gonna download my data from one of my data loggers, and they were covered in feces. And like, do you know the size of elk? They are so huge, and like you can't imagine how big that was.
Elk
and just
pie.
Elk pies.
Elk pie.
Yeah. And it was like right fresh out of the elk, I guess. So it was
steaming.
I know. It was, that's like the funniest like wildlife story that I can think of.
Oh my gosh. Did it take you a while to clean up everything then? Or
oh my god. Yeah, we had to grab like plastic bags and just kind of like move it, but then we didn't want to leave the plastic bags like, you know, in the wild, so we had to take it with us, which we thought was like also a huge mistake. So just like in the trunk of the car, like, oh, it was a bad time, but it's funny now.
Yeah. It's always funnier when you look back on it. It's type 2 fun, right? Is what we call it. Yeah. Have you ever like seen any bears or anything, or
No, we've never seen any bears, fortunately.
Yeah.
I have met another researcher. He's not a researcher. So the river that we're doing our study on has been monitored before by the Critical Zone Observatory. And so they have like a little flume where they have like a lot of discharge data that we're actually using to do all our calculations. And so we met him because he one day went and downloaded the data from the pressure transducer, and he told us that he once saw a baby bear and his mama.
Oh, jeez.
I know, very, very scary. But I think the bear population in the park is like really controlled. Like the park rangers know how many bears there are. And, I haven't seen a bear, fortunately.
That's good. How about rattlesnakes? Have you seen any rattlesnakes?
No, I haven't seen snakes either, actually.
Oh, nice.
Yeah. I've seen I only seen the good stuff. I've seen like the prairie dogs and like ravens and foxes, but no rattlesnakes, no bears.
Marmots? Are you up high enough to see marmots?
I'm not sure.
You might not be up high enough, but they're really cute. Like they'll chirp to each other. They'll sit on a rock and chirp to each other. They're like they look like smaller gophers, basically. But they're so cute. You should look for some marmots this summer while you're down there.
I'll keep an eye out.
Okay. If you could describe your work using an analogy, what would it be?
So for this, I think I need to talk a little bit about what my research is in a bit more detail. So remember I talked about the threshold of sediment motion, and that's basically like a calculation of like what flow or what shear stress is high enough to move the sediment. And so this threshold always changes in time. That's why we think about it in like seasonality for like the nutrient release and everything, but it's not necessarily controlled by the seasons. It'll just change. And for the last like 50 years, people have just like assumed a specific value for the onset of sediment motion based on like grain size and the river geomorphology. But it has been proven by a lot of researchers that this is not a constant. It changes through time. And there have been a lot of studies that show that how this threshold of the onset of sediment motion changes based on flow history. So depending on the previous conditions of like the water, either being the flow magnitude or how long it's been exposed to a certain magnitude, will influence what this threshold is. And so I like to think of it, or in terms of like an analogy, is that rivers are like elephants, because elephants are known to like have really good memory. And so a river basically reacts based off of everything that happened to it beforehand, like all the antecedent conditions. And so my research is basically understanding the elephant in this case, trying to predict its reactions to what happened to it previously, because it will always remember what went or what happened beforehand.
That's such a cool analogy. That's awesome. I would have never like put the two together, but the way that you described it was so perfect. It was so awesome.
I'm glad.
Yeah.
You're just studying the elephant in the room.
I was gonna say, yeah. Elephant in the wilderness.
Yeah.
Really cool. So rivers have memories.
They do.
Yeah.
I think that's like also like a famous quote on like rivers always have memory based off of just like river migration in general.
Mm-hmm.
But this is like a new take on it where it also remembers just previous flow conditions to react to.
Yeah.
In this case, when to start moving sediment.
That's so cool. That's like super cool to know about.
I know, and it's really new and it's like really fun to think about. Because, and I don't know if you guys know, but in hydrology there are like a lot of assumptions that people make when they do calculations, which to me really frustrates me because we can't always assume things that we don't know are true. Mm-hmm. And that happens with the threshold that I was talking about. And so having a better understanding on how it changes and being able to predict it will give us better insight on all those things that happen.
Yeah, that's really cool. That's why like the sciences will always have positions, because it's like we'll just never 100% know for sure. Mm-hmm. Like, and we just have to keep building on prior knowledge and trying new things in order to figure out the answer more accurately. So.
They're called theories for a reason. So.
That's right. Mm-hmm. Yeah. Good job, Brian. Okay, so we're gonna get into if you have any fun stories from the field. So you already told us about the elk poop, which is pretty hilarious. Do you have any other ones from the field that you want to share with us?
Yeah. Actually, a lot of things have happened in the field. So I can name a couple, as they always do.
Yeah.
So some of them are like funny haha, and like they're actually funny to think about, and others that were pretty devastating at the moment and were pretty like detrimental to my research. Mm-hmm. So let's talk about the funny haha first. So I don't think this is like a common thing in national parks, but I think since the Valles Caldera is a national preserve, it has different rules.
Yeah.
But it has like hours in which it's open. But unlike, for example, other parks where like you can still go in when it's nighttime, they have like a lock, and there's like a huge gate where you can't go into the preserve after like 5 p.m. And so us as researchers have access to the code for the locks so we can stay after hours. And they change the codes regularly, like once a month, so they don't always have the same one. And we weren't aware of this. And so we only had the code for July, and I think they changed on like August 2nd or something. And so we had stayed pretty late that day. It was around like 7 to 8, so it was already sundown. We were super tired, very excited to get into the shower, have a nice dinner, get into bed, and we wrapped up, we headed out, and when we had to put in the code for the gate, it didn't work. And we tried for like at least 30 minutes, and we tried like different combinations of like the same code and like why is it not working, and we started freaking out because it was 8 p.m. it was almost dark out, we had our truck with all our equipment, and like what do you do in that case, right? We considered, when you're desperate you would think of a lot of things. We considered like hitchhiking or sleeping in the car that same night. Things that weren't really feasible.
Driving straight through the fence.
Well, it's a metal fence, so we would have like trashed the rental car that we had. So what we opted to do basically was to just, because we didn't have reception either. It's in the middle of nowhere. And so we couldn't call anyone to help us out. So what we decided to do was just leave the truck inside the park and just walk until some point that we could get reception and call someone to help us. And as we were like jumping the fence, we saw the tiniest little like note. It was like 15 centimeters and 10 or something that said like, are you trapped in the park? Well, call this number, which is, I don't know what physics they used for this, but right in the spot where we saw that tiny note, we got 1 bar of signal or like reception, and we called. And it was like the park ranger's wife or something. It's like the personal park ranger's number. Oh. I know. And we felt really bad about it. And he gave us like the new code, and he apologized for not giving it to us. So technically we didn't do anything wrong, but it was a huge scare out of just like desperation of not knowing if we're gonna make it home that night or not. And just the sheer luck of finding that tiny note like on the side of the gate that like you could barely see was incredible. In that one spot too, like it's so weird. I don't know if they chose that spot because that's where you get I don't know. It was magical. It was a blessing from the sky.
Oh my gosh. That's a crazy story. Okay, so that was the happy, cheery one.
Yes, that was the happy, cheery one because it was essentially a relief, right?
Yeah.
Of like, oh god, that was just a scare.
And now I'm scared to see what the other one is.
Well, I mean, the other one is kind of similar. I just think it's worse in magnitude. It's like
that's fair.
Yeah.
This one could have gone way worse.
It could have.
So much worse.
Gotten eaten by a bear in the park, sleeping in the truck.
Service.
Yeah. Well, the second one, I don't know if we can separate those actually. They're probably very similar. But the second one is basically how my site almost caught on fire, or the preserve actually almost caught on fire. So this happened about a year ago. It was last spring, right after snowmelt, which is really weird to see wildfires after snowmelt because
it's usually like damp and
I know
more moisture.
Yeah. So it wasn't really common, and we were like wrapping up our field season, which was also pretty sad because we didn't have like flow high enough to move any sediment, so
bummer.
We didn't get any data from that field season. It was a huge bummer. And it was right after Easter, and there was a wildfire going on like one of the hills close to the park, and they had closed all the roads to get up to the park, and we had all our equipment still installed. I had like expensive sondes, I had ISCOs, which are just like automated samplers. I had like all my batteries, all my data loggers. I had everything up there, and we didn't have permission to go back up there because it was dangerous, and we thought that we were done for. We thought that all our equipment was going to burn and that I would have to quit and move back. It was a bad time. But fortunately, we contacted one of the park rangers and told them about this issue. And a lot of people were already working on having the wildfire not spread to the preserve. So it was all pretty well maintained. And so we asked this park ranger if we could go retrieve our things. And he gave us permission with the condition of having an escort with us. And so the day that we went, we felt like celebrities because they were like police officers not letting people like access the roads and stuff. And we were there kind of like in our like field clothes, just like ready to, we looked like regular hikers, honestly. And the police officers were like, no, you can't go up there. And we were like, no, but we have permission. And then we have this park ranger escort be like, no, they're with me. And we just kind of like go and pass through the police officers and get to the site, and like in 30 minutes we had all our equipment back with us. It was like
that's crazy.
Speed running, dismantling. And the site didn't burn in the end, so that's like the good news in all this, right? But it's just like a huge scare of like what would have happened if it wouldn't, or if we couldn't have retrieved our equipment.
Yeah, equipment is not cheap.
I know it's not. So it was pretty scary.
Well, that had a happy ending to it. So,
yeah, everything goes kind of well in the end.
That's good. Yeah, we get a wide range of like field stories here. So some of them are really funny, and some of them are like, like I lost all my equipment and my data, and that sucked. But
sorry, mine aren't like really funny. They're like little jump scares.
Yours are funny. Just like you said, they're like type 2, like funny. Like
good.
Yeah. But we can get back to a funny question. So I'm gonna ask your first serious question.
Serious question.
How would you solve a scientific problem if you were from Saturn?
Okay, I like this question. I realize that you ask everyone this question, and I think it's really fun because it's like very creative. It's a very creative realm of, finding out an answer.
Thanks.
And so
that was the purpose of it.
Awesome. That's great.
It's like serving its purpose.
So I like Saturn because this was back when I was a kid and I was learning about the planets and like the concept of density. I think I was watching like a YouTube video on, I think it was like Crash Course from like Hank Green or something.
Oh, I love those.
Those are awesome.
I love the Green Brothers.
I know. Yeah, and they're really good at explaining things. And so the way that I understood density was that he compared the density of water to Saturn, and he would say that if you would put Saturn in like a tub or a pool, it would float. It would be like a planet floaty, or a floaty planet.
Mm-hmm.
And so I think my question, if I was from Saturn, would be how many liters of water would I need to fill up a pool to let Saturn float on it?
Just be like the solar system like pool floaty.
Yes, exactly. And having the Earth sink probably because it's really heavy, but Saturn would be floating, just chilling there on the pool.
I have a question.
Scott has a question.
Do you think, is Saturn cold enough that it would freeze the water if it were in a pool?
That is a good question. And do you
Maybe.
think that it would like float and freeze it at the same time?
I don't know. I feel
Here's
like
the thing is that
physics guy would know.
water freezing doesn't just depend on temperature, it also depends on pressure.
Yeah.
It also depends on like volume of water and whatnot, so
It's a crap load of water.
yeah, it would be a lot of water, but if there's no pressure at all, it would actually freeze like really easily, so
Oh
yeah.
Huh. Interesting.
I wouldn't know how to answer that.
I'm into the floaty idea.
Yeah, same.
Yeah. Totally get rid of the unicorn floating.
So let's just start filling the observable universe with water, and we'll
Yeah,
get
and
there eventually.
see.
You know? Yeah.
Precisely. Would it
Everyone turn your hoses on all at once.
would it mess up the orbits? Would the sun go out? Who knows?
Yeah.
Oh gosh. I'll leave it to us to mess everything up.
One way to find out.
Can the sun float in water?
Can it?
I don't know.
I doubt
Probably.
Density of
It's gotta
the
be
sun.
more dense
It's
than
mostly
water.
like hydrogens and stuff,
Oh.
I'm pretty sure.
it. Yeah, hydrogen.
Helium.
Plasma.
Yeah.
Whole plasmas.
The
Yeah.
sun is very crazy though. Like,
It would be explosive probably if you put it with water.
Oh, yeah.
The water would vaporize instantly.
Yeah.
Probably. Yeah.
Well, if it was the same mass as the sun of just water, you combine the two of them together.
The sun is a little
Sounds
bit heavier or is a little bit more dense than water. So
Really?
it would
Wow.
not float. Yeah, it's 1.41 grams per cubic centimeter, and water is just 1 gram per cubic
Wow.
centimeter.
Wow. Surprises me.
40% more dense. Wow.
Interesting.
I guess
Right.
that maybe that does make sense because at the center it's making like really heavy elements, so
Yeah.
that's probably why.
But also, it probably would just explode.
Yeah.
So, I'm more concerned about it like exploding than like, sinking in.
In water.
Yeah, not being the best floaty at all. Okay, Nicole. Well, now we get to a part of our show where we ask you to explain your research to 3 sort of different groups of people. Your elevator pitch, if you will. Because we all know as grad students, it's the one thing we always love doing. So the first group of people I'm going to ask you to describe your research to is like an elementary class, like a 4th or 5th grade class. How would you explain what it is that you do to them?
5th grader.
Okay. So I think in simpler terms for 4th to 5th graders, they're actually like really smart. Like we can't underestimate kids.
Yeah.
They know a lot, but there are a lot of concepts in like river science that we can't assume that kids know. So I'll just leave it in like simple terms. So basically, when you have a river that has large rocks in it, because we have different types of rivers that are only like in the bottom we only have sand, and some are a mix of both, and some are just gravel. Gravel are like bigger rocks, right? And what I'm studying is basically the movement of these bigger rocks. So whenever these rocks move, when you have more water going through them, more water will mean that you will have a bigger force that will be able to move them. And so I want to know when these rocks will move and how much finer or smaller rocks will be suspended in the water or will float in the water whenever these bigger rocks are moving. And so I want to know basically how that movement of rocks changes in time, if that makes sense.
Yeah, that's a great answer. Yeah, I appreciate that answer. I think like that's well explained. Okay, so the next set of our group of people that you have to describe your research to would be like maybe a high schooler or maybe an undergraduate who knows a little bit about rivers, like has some general knowledge of the key concepts, but doesn't know exactly what it is that you're studying. How would you explain it to them?
Undergrad.
Okay. I think the way that I first explained it is around that term, I think. If we don't know much about rivers, we know that discharge is just the amount of flux of water that is coming in, right, to our system. And when we think in terms of threshold for sediment to move, it is very variable. And I'm just interested in seeing how the change in this threshold will also influence the release of nutrients and fine sediment into the water column.
Nice.
Cool.
Yeah,
Excellent.
definitely got that for sure.
Cool.
And then lastly, how would you describe, and I think you've done a great job of this, but in a very concise manner, how would you describe what it is that you do to a professional at a conference?
Expert.
So this one's easier for me because this is what like I always do. It's like talking to actual like water professionals.
Yeah.
So when I talk about like the seasonal or the temporal variations in nutrient releases, we express them in terms of hysteresis patterns, which is basically like a Q or like a discharge to concentration curve. And so the initial hypotheses to my dissertation is how these hysteresis patterns change in time. And so I like to say the release of nutrients in simpler terms, but I am essentially studying hysteresis curves and how these curves will change depending on the threshold of sediment motion. So in like professional terms or like more technical, I am basically studying the temporal variability of hysteresis patterns and how the change in the threshold for the onset of sediment motion control them.
Nice. Yeah. Brilliant. That was really like articulate, very concise. So
I'm glad. Thank
well
you.
Done.
So that's like the ratio, what you said was the ratio of like sediment to flow versus time is like what you're plotting there essentially, or?
Yeah, so when you have like a hydrograph, you have time on the x-axis and you have like the flow or the peak of concentration of whatever constituent you have.
Okay.
And so depending on where the lag of these both peaks occurs, so sometimes we'll have like the peak of, or let's say we have the peak of discharge, and depending on if the peak of the sediment in this case is like before or after the peak of the discharge, you will have a different hysteresis curve.
Yeah.
So I'm trying to see how the threshold of sediment motion controls where this peak will occur.
Okay. Interesting. Cool.
That is cool. I'd like to see your graphs.
Yeah.
I can show you some if you want after this.
Yes, please.
I can
That's
vouch
awesome.
for her. The graphs look good.
Yeah.
Yeah,
Thank
they're
you.
cool.
Nice. Okay, well now we're going to get back into some more serious questions to sort of wrap up this awesome, epic interview that we've done with you, Nicole. So the first question I'm going to ask you is, what's your favorite activity outside of work and research to do on a river?
It's a good one. Outside of, I think it'd be rafting, honestly.
Yeah.
I love rafting. It is so fun. I am really bad at it. I have fallen several times.
Yeah.
But yeah.
Do you do like whitewater rafting or just like what type of rafting? I guess. Is it just like mellow rivers that you're on, or do you do like rapids and things like that when you raft?
I think I do like the easy stuff. I don't know if, well, maybe my concept of rafting is like different because I've only done it in Chile. I've never done rafting here in Boise.
Okay. Oh, cool.
So yeah, to all my Chile lovers, or anyone that has like gone to Chile. I think you've actually been to Villarrica. You went to
all
Yeah.
three of us
expedition.
actually
Oh
were there.
wow!
Yeah.
Awesome. Yeah. So like Pucón is like one of the biggest like whitewater rafting like hubs in like southern Chile.
Really?
Yeah.
No no idea.
Yeah, I know a lot of people who are obsessed with it and
Like the Rio Turbio?
Um,
Probably is a big. Remember the Rio?
Yeah, I guess
It was
so.
like the
That
major source of noise for us.
That didn't
during
seem like
our
it was-
volcano
I know.
series.
I didn't see many people rafting
I don't.
down
Yeah,
that
we were
one.
there in the summer too. So
Oh, yeah. Must have been a dry year. Or
maybe.
something, but-
Yeah, because a lot of people go rafting there. But it's like group rafting.
Mhm.
Like, I don't know if there's like individual. I think that's kayaking.
Yeah.
Maybe?
Well, yeah. So it depends on the watercraft that you have.
I
but,
see.
yeah.
Yeah, well, when I do rafting, it's like a very big one. If it's like 6 to 8 people.
Yeah.
And we all have our little rows and try to
Mhm.
move it around. So, yeah. But nothing complicated, nothing dangerous. I am by no means an expert, so.
No. But you can, so I'm wondering, because, in here and in Colorado and a lot of places, you can do those group raftings, but it's like whitewater rafting where you're actually going down, rapids and stuff on rivers, usually during high discharge because...
Mm-hmm. But not too high, because it can be dangerous, right?
Yeah. Unless you're,
really good at it.
really good at it, which even then. But yeah, so is it the same in Chile then? It's
yeah.
You're
it's
going
just,
down rapids and things like that.
But it's
Okay.
more mellow. It's not as extreme, I
Yeah.
would say. Or at least not the difficulty I've done.
Yeah. That's fair. Yeah. I've, honestly, probably the last time I went whitewater rafting was when I was 10. So.
Yeah, I haven't been in a while.
But there's a,
It's been 3 years for me, but I miss it.
Yeah.
A cousin who came to Colorado and whitewater rafted from St. Louis and got thrown out.
Oh my gosh.
They have all these horror stories, so I'm a little bit afraid of whitewater.
Yeah.
I respect and fear it.
Yeah, even on some of the mellow stuff, I know people whose rafts have tipped up, have really honestly had some really frightening things happen on whitewater rafting. And I think it's just purely because they just went out too soon on the river. It was just the discharge was high enough that it just made it a little bit too turbulent in some of those sections.
Yeah, I think it's most fun when the flow is slightly lower.
Yeah.
And it can be safer.
Yeah.
we need to just get you on the Boise River.
Yeah.
She's
Maybe.
always gone during
It's
the
like a
summer,
lazy
though.
river.
Exactly. I'm always gone during the summer for field season, so
Yeah.
I've never floated down the Boise River.
Yeah.
Yeah.
It's only open for a small window
I
too.
know.
So.
But I really want to do it.
Well, unless you just want to have your butt dragging along
True.
the bottom of
Yeah.
the river the
Yeah.
entire way down, which we've also done.
Yeah.
So.
Yeah, that happens when it's open too, actually. So
Yeah.
sometimes.
Well, that's really cool. So, rafting. That sounds like fun. In terms of being in Chile, what would you say is and this doesn't have to be on a river or anything, but what would you say is your favorite place in Chile to go explore?
That's a good question. Well, I'm from the south, so the climate and vegetation, everything is perfect.
Mm-hmm.
It's right up my alley. Yeah. I'm thinking of where I would. That's a good question.
Sorry.
No, that's good. Because the first thing that comes to mind is my hometown, right? But I'm obviously biased because my family is there, and all my friends are there. So.
Where is your hometown?
It's Temuco.
Okay.
So if you were to go to Villarrica, you probably flew into
Yeah.
Temuco and then took a bus or something.
Mm-hmm.
So yeah, that would be my first answer. But if I had to vacation somewhere, it would probably be the Calafquén Lake. It's right next to the Yaima volcano. I don't know if you've heard of it.
Yep,
Yeah,
we visited
were
that
there.
too.
Awesome. Yeah, I that is like one of my favorite areas because my parents would always take us camping there when we were kids, and so I know a lot of like, I've explored that area a lot, and it brings back really good memories, and
That's awesome.
I really like it.
Yeah.
Is that
But-
where we swam?
Yeah, it was.
Was that the name of the lake? Was it in the national park?
Glacier
No, it's not a national park. It's like, have you guys been to Licanray? It's like the town, or like the biggest town.
I don't think we
Right
did
now,
go there.
Is that where we had empanadas?
No.
No. We had empanadas right outside of the park, out of Yaima National Park or whatever it is. That,
Okay.
There was a little glacier-fed lake that was close to it, and it was super clear. but like really cold water. That's what you're talking
Yeah.
about. Right?
Okay. No, it probably wasn't.
You're
Calafquin is
talking
pretty
about a
big.
real lake.
It's
yeah.
pretty big.
This is like a swimming hole that we just found.
I see.
Yeah.
Well, if it's not that, and if I were to like go on like a bigger vacation, I would probably say the Patagonia.
Mm-hmm.
I went to Torres del Paine like 4 years ago, and I'm obsessed with it. And
Did
I would
you like
definitely
just
go.
camp there? Or
Yeah.
Oh my god.
I know. They're
What a
like
view.
It's insane. It's crazy.
That's awesome.
And it was pretty miserable because I got sick on like the second day of the hike.
Oh no! Like altitude sickness or like?
No, it was a cold. I was yeah. So it was pretty sad. And then after like 2 days of hiking with like a massive headache, I got over it. But it's a stunning place to be in, and I highly recommend it.
Oh my god, yeah. I don't know. I've read a lot of stories from that area. I've seen a lot of pictures. Scott, have you been there before?
Not yet.
We should plan a trip.
Yeah.
Love to.
We're all going to Chile.
Yay!
We need a GoFundMe for EpicEarth posts and
Yes.
Nicole.
Yeah.
We accept donations.
Yeah.
I can be your tour guide.
Okay, and last question, just to be really silly. Let's see. Do fish get thirsty?
I've never thought of that. I have never thought of that. I want to say yes. I want to think that they do get thirsty. And the question then lies on whether do they just drink whenever they do feel thirsty? Like just not inhale the water, right? But just like take a sip like they do with food, or do they feel thirsty as they feel hungry at the same time? So whenever they do eat something, they're consuming both water and food? Or do they not get thirsty because as they eat, they're like consuming the water? So I don't know. I honestly don't have an answer to that.
These are all great questions.
I know.
And really great research questions.
Have any biologists studied this? This is excellent.
You know, I think we asked this once to Mac before on our podcast, and he said that he thought they also get thirsty, but they get thirsty for oxygen, not necessarily for the whole molecule. So,
I was thinking of just like water.
I know, but then you have fish in the ocean, so you know, that's I don't know. It's I don't have an answer for that.
No, but that's actually a really good point. They do get thirsty for oxygen because depending on anoxic zones or like eutrophication, things like that, which happens when you have excess nutrients in rivers or like stagnant waters. You have like a lot of like microbial activity, and sometimes the microbes will consume all of the oxygen and not leave any for bigger species. So like micro or like invertebrates or fish in this case, and so that's why you see a lot of like just big fish kills because they're out of oxygen.
That's crazy.
They just float through an area that has like depleted nutrition for them, and they just
and sometimes they'll avoid it, but sometimes the reach is so long that they can't, and they end up suffocating.
Yeah.
So it's pretty sad. Pretty sad note to end on.
Yeah.
What do you think like the weird creatures at like the very depths of the ocean like survive off of? Like just nutrients? Because it's pretty anoxic down there, right?
You mean like the Kraken, right?
All the dead stuff that's just
like the Kraken. And, all those weird things that you see on like National Geographic.
Yeah, well, the Kraken's diet is about 80% human.
Pirates and...
it's abandoned. It's like broken down ships that sink down.
Oh, yeah.
Just wood and
debris.
Well, what about like dolphins, though? Dolphins, do they get thirsty for water? Because they just breathe air. Same thing with whales.
Oh, yeah,
how do
that's
dolphins
true.
and whales get hydrated?
How do we get
Do they get hydrated?
So you know how like when they go up to the surface and they kind of like expose all the water that is with it? I think they might have some kind of like osmosis thing going on inside their like soft tissue or something that will like, I don't know, maybe secrete water that is needed for them, and then they'll just like get rid of the rest. Maybe. That is a good question.
That's super impressive.
I know. Well, aren't all these creatures like super impressive though?
Yeah.
We need like marine biologists on the show.
Yes.
Oh, my sister's friend is a marine biologist.
Oh, there you go. Okay,
we
well,
could- I
we'll
could
get
totally
all of
ask
our
her.
answers on
Oh,
one
yes.
of our shows.
I will stay
I'll
tuned for
seriously
that
ask her.
episode because
Cool.
those are good questions that I have never thought about.
We always end up talking about fish at the end.
I know, I'm sorry. I don't know what's
It's
happening.
not even just you.
fish.
I've done it too. So.
Oh no. Well, okay. We ended that on a great note. So Nicole, thank you so much for doing this interview with us. You did awesome. We're excited to see where your research takes you. You're gonna do amazing things, and yeah, let us know if you're ever headed back to Chile, because we want to hop in your bags and go with you.
Sounds good. I'm probably going for Christmas this year, so
Oh.
right when it's summer
perfect.
down there.
Yeah.
So you now know.
Yes.
Well, yeah. Thank you for having me. It was a pleasure.
Yeah. Well, to all of our listeners, thanks for listening, and we'll be back with another episode pretty soon. Take care, everyone.
Have an epic day.
Well, that was an epic conversation.
We'd like to thank all of our listeners.
Tune in next time for another Epic Earth podcast.
Yeah.
Like, talking about myself is so strange.
I
Sorry.
know, right?
Okay.
Are we 75% water?
I don't.
It's like 80 or something.
Yeah,
it's a lot.
it's
Yeah, Jesus. That's why we love rivers so much, you know.
Oh, yeah. Yeah, just be sure to take this part out. To all my Chilean lovers, that sounded weird. To all my